Recording. Okay. Good evening, Physics 2523 Professor Storr. My name is Khuzaymah Ahmed. I am currently a student in at Prairie View A&M University, studying electrical engineering. I'm actually a transfer student. I transferred sometime last year before COVID. Anyways, I chose my project to be about how a solenoid switch works, right? And let me share the screen. Before I get into that, the reason I chose this was because I feel like I can explain it in a way that the listener, the audience, can understand what I'm saying, and they can understand to what I'm trying to get to, and they can also know the material as well. So without further ado, I'm going to show my screen to present the PowerPoint. Okay. Let me put that to the side. Oops, not that. Okay. Well, as I said, how do I move that thing? Whatever. As I said before, my project is about how solenoid switch works. My name is Khuzaymah Ahmed, Physics 2523, and my professor is Professor Storr. What is, first and foremost, you need to get to the bottom of what exactly is a solenoid switch. And a solenoid switch is used to switch high power circuits using a smaller electrical control signal. It's used in starter motor circuits and brought into operation by a low current switch. Basically, as you see in the picture, in between the little cylinder, there's two magnetic forces, right? And that wire running at the bottom, as that gets power, the magnetic forces pulls or pushes, depending on which way the solenoid is working towards. It pulls or pulls the plunger. So if it, as the magnetic forces, they turn on, it attracts the plunger, which is how it turns on. How it works is there is the coil wire, and there is a movable plunger, which I said in the middle of that little cylinder looking thing. When electrical current is introduced, a magnetic field forms around the coil and draws in the plunger. Excuse me. It draws in the plunger, like I said, the magnetic forces getting the power from the electric current. The solenoid then turns on the switch for yada, 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 whatever it was, meant to do. So that diagram on the right, I don't know if you can see this little thing, but I can definitely see it. Anyways, there's a start switch, there's a battery, there's a starter motor, and there's a solenoid in the middle of all of them. Basically, it's given the commands from the start switch to the battery or the starter motor, and it's given the command of what to do. Some of the things that it's used in is automobiles, such as not exactly more like the fuel systems, like the brake systems, and like something in the transmission I read it uses solenoid somewhere in the transmission. I know that it obviously, like we saw in the diagram before in the slide, it sends a signal to the battery, which a car nowadays, batteries are what they operate on, but even solenoids are more technically, more in the advanced era than they are in the olden times, from what I've read. It's also used in industrial usages such as circuit breaks, medical respirators, cabinet locks, bank ATMs. I bet cabinet locks is probably just a smaller or like a more simple version or version of them. Fire suppression, that's also one. The equation of it is the solenoid equals the magnetic what is that? The magnetic constant times the number of turns times the current, all divided by the length of the solenoid. That's how you can solve for the solenoid magnetic flux density. Oops, and that's it. Let me go back. No. Let me go to full screen. Okay, well, I stopped the recording. I stopped the screen recording. Other than that, that's about it. I need to just submit this and hopefully I should get, well, thank you so much for listening. If I hope we can speak soon sometime. Thank you very much. Have a good one. Have a good weekend. Bye.